Alright everyone, so this is Aidan here. It was a pleasure working with Aidan. He was a very curious student at Bootcamp. I remember like from the very first day, he'd always call me over and ask how to wire this component or if my wiring is right. And he'd always be flagging me down. And together we worked so many hours, and there were some down moments when we short-circuited a whole Raspberry Pi. There's definitely some up moments too, and we're going to see that right over here with Aidan B's ball tracking robot project.
I go to Homestead High School and I'm an incoming sophomore. At my time at Bootcamp, I designed a ball tracking robot. So I chose the ball tracking robot because I liked working with motors, and I thought having a mini computer follow a ball was pretty cool. So that's why I chose it. So one sentence explanation is basically that it's just a Pi camera that tracks a ball, and the motors respectively spin towards the ball. And it also added a mic. The mic overrides the car's motion, and it just follows basic voice commands. So, just a live demo. So at first, my car won't start unless there's actually a ball to be there. So as you can see, it follows my ball really well. And if I take it off the screen, it automatically starts spinning because there's no logic detected. And I actually tweaked around this a little bit. And so if I take it off the screen one way, it starts spinning that way because it assumes the ball left the screen over there, and it's very fast. And it works for both ways. So, and initially days, if I take it off the top, it was completely stopped. So, and another modification I added is a basic voice commands, but I repeat it multiple times because it doesn't take it in. Forward. So you can see both motors are spinning forward, and it only lasts for 2 seconds, and it goes back to ball tracking. Stop. Stop. Yeah, so both stopped and down there. So basically how I did this, so I initially started the project by first working on my motors. So I first wired my motors to the motor driver board, and there was no way of changing the speed before. So I had to take out the enabling pins and use PWM. PWM is basically rapidly turns the pins on and off really fast, and it adjusts the power sent to the motors. This was like one of the only ways I could use to change the motor speed. So now how did I do the ball tracking? So number one, I had the Raspberry Pi extract all the hue from the camera image. This basically masked out all colors besides red, and I basically found the largest red object. Step two, once I had the largest red object, I had to check if it was real and large enough. Once it was real and large enough, I could then find the center of the ball because I already found it, and I could check the balls from the left side of the screen or right side of the screen or middle. Say the balls from the left side of the screen, I had the motors rotate until the ball was centered, until the camera was centered to the ball, and then it would move forward. So some modifications I added was a double decker. The double decker was one of the fairly easier modifications because all I had to do was add 4 standoffs. This is very good for space management and weight management. Just let our motors be around, like have the same weight on them and allow them to go at the same speed. This is really easy. Another modification I added was the last scene. So as I showed before, if I move the ball on one side of the screen, it starts turning that way because it assumes the ball left the screen there. And this is a good modification because it led it to finding the ball faster rather than going a full 360 degrees. And the last modification I added was a mic. So once I had the mic, I could say basic voice commands like forward, left, right, and stop. This will basically override the ball tracking code. I did this by importing a library called threading. It allowed it to all work at the same time, but it would always be listening for the mic. So some challenges I faced a lot of pretty small challenges which required me to replace a couple parts. But the biggest challenge I faced was frying my Raspberry Pi. I connected my battery pack to a battery pack 12 volts into my Raspberry Pi's 5 volts by not properly looking at the wires when I connected to my breadboard. this actually led into my Raspberry Pi being smoking, and then it was like no smoke everywhere, and then when I touched it, my finger actually burned. So, and then my screen went black, so it's pretty bad. And so my next steps for me, something I would actually change about this is try to have a Bluetooth mic. Instead of like picking it up and talking to it, I'll try to have like a mic over here so I can speak to it. And another thing, something I learned from BlueStamp is always double check, because I didn't want to like burn another pie. Yeah, so also something I also love with BlueStamp is OpenCV. Working with OpenCV was so fun, because like in the future I would love to study more computer vision. Thank you. Any questions? Yeah.
So after the voice activation, it still starts the ball, right? When you override the voice activation?
Yeah, it lasts around 2 seconds and then it goes back to looking for a ball. Yeah.
What was your favorite part of making the ball track?
Obviously working with Mass, because Director Sam, Mr. Sam always helped me through it, and it was really fun working with Mr. Sam. Oh yeah. Go ahead.
Would you have to change if you wanted it to track something that was not red? Or like,
So basically, I had like 2 color ranges specifically for the color red. I could actually just change those if I look for different colors, like specifically yellow, because Neurologic wanted me to track other motors so I can run into them. So if I just change the ranges, I'll be fine.
How do you know which way to move?
Which way to move?
Which wheel to move?
Like so there's like, so there's motors, and then you connect them to the driver board. There's 2 on each side, and you basically set the pins on the code. So once you have the pin set, you can like move them however you want. You have any questions?
Claudia stole my question.
Oh. Alicia.
what did you learn about ground?
About ground is that like all this like you need ground to make everything work together, because all the signals and the powers have to flow through all the components. Alright, thank you.